Another type of loop that MATLAB supports is the while loop, or in other languages it might be called the do-while loop. And it functions similarly to the for loop, except instead of using indexing like the for loop does, it's going to repeatedly test a condition, and while that condition is true, it will run the contents of the loop, and once that condition is then false, it exits the loop and moves on. So for example, if we say while k less than 10, we want to do stuff that's inside here. So we can say k equals k plus 1. Right, so what it's going to do inside this while loop is that as long as this condition, this logical test is true, it's going to repeat the contents inside the loop. But then you're going to need something that changes the test condition. So if we don't have anything in the loop that ever makes k greater than 10, this is just going to run infinitely. So let's just see what happens when we do that. And in the for loop, another thing the for loop does is it initializes that test. In the while loop, we have to make sure that we do that on the outside. So let's see all these things that we do have to be concerned with that are taken care of if we use a for loop rather than the while loop. So if I just try to run this loop, it's not able to do it here because I've never defined the value of k. In the for loop, that's automatically defined because we give it the initial value of the index variable and then what the test is at the end. Is it less than or is it greater than that end condition? Here, I have to give k an initial value, otherwise, when it comes down here for this test, since k is not defined, it doesn't know if that's true or false. So if I, what we call initialize the value of k to 1, now, if I go and I do this test, that's true, which means it's going to enter that loop. Now here's the part we have to be careful of with a while loop is, again, we need to have a way to exit the loop. If I just run this, we see that it just keeps printing the value of 1 because the value of k is always 1. Nothing inside this loop changes it. So it just keeps printing this, and it'll keep doing that forever unless I stop it with Control-C. So that, again, breaks the current command. The way that this is set up here, the value of k was never changing, so it can never be false that k was less than 10. So if I uncomment this line here, and now I have a way to change the value of k, now if I run this loop, it does terminate successfully because I'm changing the value of k, and that's what is eventually going to make it false that k is less than 10. So once I'm out of the loop, if I look at the value of k, it was equal to 10, and 10 is not less than 10. If I change this to equal and I rerun this, now it stops when k is 11 because we see that here, that last value, it went through that while loop, added a value of k, value of 1 to k, and then when I tested it that final time, 11 was not less than or equal to 10, and it kicked me out of the loop. While loops are useful for different reasons than for loops. Number one, when we use a for loop, we already know, or we often know upfront how many times we want that for loop to run. So we want to test maybe every value of x in a vector, and then evaluate it so that we can fill in another vector y, like we looked at in the previous example. But for a while loop, those are useful for times that we don't necessarily know how many times we want to run a certain section of code. For example, let's say we just wanted to run something for 5 seconds for some reason. So we can initialize with a tick. And I'm going to initialize this value of time to be 0. So I want to run just a section of code for, let's say, 5 seconds. So run this as long as the value of time is less than or equal to 5. Now I'll initialize k to be 0. So let's see what we're going to do in this loop. While we're in the loop, I'll just keep adding a value of 1 to k. So it's doing some function. We could add more if we want a more complicated function here. And at the end, I'm going to equate Tim to talk, and then keep testing that. Right, so this is going to run for about 5 seconds here. So if I look at the final value of time, it was actually right on 5 seconds. And if we see the value of k, this repeated itself almost 2 million times in that while loop. So in that 5 seconds, it added k plus 1 almost 2 million times. Let me make this shorter if we just run this for 2 seconds. Right, so again, our time, once it reached 2 seconds, it exited this while loop and was able to run the contents of that while loop about 750,000 times. Depending on your computer, it's going to run the contents of this a different number of times. But this is the type of thing we couldn't do with a for loop because we didn't know beforehand how long it would take or how many iterations would run in this example 2 seconds. In another example where we might not know how many iterations it's going to take to do something, so let's get rid of time here. Let's look at a Fibonacci sequence. Okay, so let me clear the contents here. So the Fibonacci sequence is going to start with, we can do it as a vector. So I'm going to say here, f of 1 is 1, f of 2 is also equal to 1. What the Fibonacci sequence does is I'll say nth element of it is the sum of the n minus 1 and n minus 2 elements. And we'll see how this is illustrated in a minute here. It always starts with the first two elements as 1, and then we can start to kind of apply this rule. So I'm going to start on the third element, so I'm going to initialize k as 3. Right, so while f of, I just want to go until I have a value of 1 million. So not a million iterations, but I'm going to test when is my value over 1 million. Oops. So it's going to keep running until it hits 1 million. So the Fibonacci sequence I can define as f of k is going to be equal to the sum of f of k minus 1 and f of k minus 2. So I take the previous two elements and I add them together to get the next element. So in this case, I then have to manually increase the value of k by 1. So this is something that we could somehow finagle it to work in a for loop, but it's actually going to be easier in the while loop if I only want values up to 1 million here. All right, so again, let's kind of see what's happening. I'm initializing. Get rid of this and this. Right, so I initialize the first two elements of f to be 1. I am going to start my index at 3, so k is equal to 3. And my test is going to be, well, the k minus first element is less than 1,000. So let me just run the initialization here. So this test is going to be true because this is testing is f of 2 less than 1 million, and that is true, which means it goes into the while loop. And now I'm going to evaluate the third element of f, which is the sum of the previous two elements. Then I'm going to increase my value of k by 1. So when I go through the loop again, now I'm going to be finding what's f of 4, and I'm going to be summing f of 3 and f of 2, etc. Now this is something I definitely cannot vectorize because kind of one element is going to be dependent on previous elements. So a for loop would work in this case, or a while loop is going to work. So let's see what happens when we run this. Right, so we have our values of f. It took 30, or the 30th value was over 1 million, so it stopped. And if we look at the values that f took, we see we have 31 values here. Again, these are now the first 31 values in the Fibonacci sequence. But I didn't tell it beforehand to run it 31 times. I wanted to run it until I had a value over 1 million inside my Fibonacci sequence. So if I change this test condition here, let's say I want to find it until it's, I'll do 5 million, and we run this, we see that we get 34 elements in our Fibonacci sequence. Right? So again, 1, 1, 2, etc. Up to now 5.7 million is our last entry. Because remember, what it's doing is testing that the second to last entry is less than 5 million. Something else we can do with the while loop is it can actually handle, again, there has to be a logical test, but here we could put in multiple types of tests. So I can say run it until the value is less than or greater than 5 million, and also while k is less than 10. So in this case, both of these conditions have to be met for it to continue the while loop. If either one, the left-hand side or the right-hand side, is false, it's going to kick me out of the while loop. So let's run this. We see here that whichever one is false first is going to make it stop. So in this case, because k reached 10, it only gave me the first 10 values, and that kicked me out of the loop here. So it never reached the first case where we were greater than 5 million because k was greater than 10 at some point. If I up this to 25, we see it runs 25 times. If I go all the way up to 50, now it's not the k greater than 50 that kicks me out, it's that my value was greater than 5 million. So in this case, I only reached 35 elements because the second to last element was the last one that was less than 5 million. If I change this condition, let's say or, then as long as one of them is true, it's going to continue this while loop. So if I run this section, it runs it 50 times, because even though we know after about 34 times the left-hand side becomes false, the right-hand side here, because I have an OR statement, since the right-hand side is still true, it continues to run it. So it runs it 50 times. So this use of AND, or the function OR, we can't do that in a for loop, but we can use that in a while loop.